Welcome back to the deep dive. If you've been staring at your screen recently, wondering how on earth you're going to conquer the Microsoft Azure AI Engineer Associate Certification,
Which is quite a mouthful.
it really is. That's why we just call it the AI-102 around here. But if you're prepping for it, you are in exactly the right place. Today, we have a very specific, highly tactical mission. We are going to decode and demystify this exam for you.
And we're not just reading off the official syllabus.
Far from it. We are working directly from a step-by-step guide and a personal playbook written by an engineer who recently passed this exact certification. We've gone through their notes, their strategies, and honestly, their warnings to extract the absolute essentials.
Because passing this exam is as much about understanding how Microsoft thinks as it is about knowing the technology.
Exactly. And since you recently conquered a similar path and know the Azure ecosystem inside and out, you're going to be our mentor today, our guide through the trenches. I'll be the eager learner, and together, we are going to get you, the listener, completely prepped for what you're going to face when that timer starts.
I am happy to play that role. Because let me tell you, walking into a Microsoft certification exam without a battle plan is, well, it's a recipe for a really stressful day.
I can imagine.
Having the right roadmap changes everything. It takes it from this overwhelming mountain of documentation down to a series of very manageable strategic steps. You just need to know where to focus your energy.
So let's start with the blueprint, the prerequisites, and the scoring structure. According to our source material, you can't just walk in off the street relying on your knowledge of prompt engineering.
Definitely not.
You need a foundational understanding of at least one of two programming languages. You need either Python or C#. But wait, isn't Azure pushing heavily toward low-code and no-code solutions? Why is hard coding an absolute prerequisite here?
It's a great question, and it actually trips a lot of people up. While Azure does have fantastic low-code tools like AI Studio, the AI-102 is specifically an engineer certification.
Ah, right. Engineer being the key word.
Exactly. The expectation is that you are building custom applications, integrating services, managing data pipelines. If you don't know your way around at least the basics of Python or C#, you really need to stop and build that foundation first.
So you're saying you'll be reading actual code on the test?
Oh, absolutely. You will be reading and completing code snippets. If a JSON payload or a Python script looks like Greek to you, the low-code interfaces won't save you on exam day.
Good to know. So assuming you have that programming foundation, the exam itself is broken down into 5 key sections, each carrying a different weight toward your final score. I actually have the breakdown right here.
Let's hear it.
Okay, so planning and managing an Azure AI solution is roughly 15 to 20%. Implementing computer vision solutions is another 15 to 20%. Then you have content moderation at 10 to 15%, knowledge mining and document intelligence at 10 to 15, and generative AI solutions at 10 to 15.
But looking at these numbers, there's a massive outlier that I didn't even read yet.
There is. And if you are studying for this exam, this is the first major strategic pivot you need to make. The section on implementing natural language processing solutions.
NLP.
Right, NLP. It accounts for a whopping 30 to 35% of the entire exam.
Okay, let's unpack this. A full third of the entire certification is sitting on NLP alone. Why does that carry so much critical weight compared to everything else? Especially with generative AI getting all the headlines lately.
Because natural language processing is really the bedrock of almost every modern AI interaction, including generative AI. Think about it from an enterprise architecture perspective.
Before you can even get to the fancy generative stuff, you need to process text. Whether it's analyzing customer sentiment on thousands of reviews, extracting key entities from endless support tickets.
Or translating text in real time.
Exactly. Or building the conversational logic for a bot. NLP is the engine. Microsoft knows that if you are going to call yourself an Azure AI engineer, your ability to handle text and language data has to be absolute.
So you really can't skip it.
You have to be completely rock solid on the Azure AI language service, or the rest of your architecture just falls apart. You cannot gloss over the NLP modules. They will absolutely make or break your final score.
That makes total sense when you frame it as the underlying engine. So knowing that we need Python or C# and knowing that NLP is the heavyweight champion of the exam, let's talk about the practical toolkit. How do you actually formulate a study plan? Where do you even begin without getting totally overwhelmed?
The absolute holy grail for your preparation is MS Learn. Our source engineer made this incredibly clear. You cannot skip around and cherry pick what sounds interesting.
All right, no skipping to the fun stuff.
It is crucial to work through all the modules available in the AI-102 learning path on MS Learn, and you absolutely must complete the associated hands-on labs. Reading about an API is not the same as debugging a failed API call in the portal.
And the source mentioned you can do this by getting a free subscription or using a sandbox environment through the Azure portal, so spinning up these resources shouldn't cost you a fortune just to study.
Exactly. Cost shouldn't be a barrier. But here is the real secret sauce tip from the engineer's playbook, and it's something a lot of test takers overlook until they are sitting in the hot seat.
What is it?
When you are going through MS Learn, you have to pay very close attention to the directory structure for each AI service.
Wait, navigating the directory structure mid-exam? Isn't MS Learn notoriously dense? How do you keep from going down a documentation rabbit hole while the clock is ticking?
That is exactly why you have to practice navigating it beforehand. During the actual exam, you have access to MS Learn. It's an open book element, which sounds great in theory.
But I'm guessing there's a catch.
The catch is the clock is ticking aggressively. If you don't understand the directory structure intimately, you will burn precious minutes just trying to search for the right module. The search function in the testing environment can sometimes be clunky.
Oh, that sounds stressful.
It is. Knowing exactly where to look for specific documentation, like knowing that the Python SDK examples for entity extraction are under the language node and not machine learning, is vital.
So you treat MS Learn like a reference dictionary, not a novel.
Precisely. You only jump in when you need to verify a specific syntax or parameter, and you need to know exactly which section to click into.
That is a critical warning. It saves you from that testing center panic where you're just wildly typing search terms and hoping for the best.
It really does.
Now, while we're talking about the labs and the hands-on work, the playbook stresses two tech skills heavily: REST APIs and SDKs software development kits.
And this isn't just conceptual theory either. The playbook warns that you will face direct code-level questions on these topics. You must know how to build secure solutions for image processing, NLP, knowledge mining, and generative AI using both REST APIs and the language-specific SDKs.
So you can't just know one or the other.
No, you have to know how your code actually authenticates and interacts with the Azure endpoints.
To put that in perspective, why would a developer choose one over the other? Why does the exam test both?
It comes down to architectural requirements. You might use an SDK because it's convenient. It wraps the API calls in native Python or C# classes, making your code cleaner and handling retry logic automatically.
Makes sense. It's faster to write.
Right. But what if you are building an application for a lightweight edge device or using a language that Microsoft doesn't officially support with an SDK? In that case, you have to fall back to a raw REST API call using something like CURL or a standard HTTP request library.
Ah, so the exam wants to ensure you are versatile enough to handle both scenarios.
Exactly. You need to be a Swiss Army knife.
I know MS Learn is the official source, but sometimes reading Microsoft documentation makes my eyes glaze over. Did the engineer mention any video courses or quick hit resources to break up the reading?
They did. The engineer highlighted a couple of optional but highly recommended resources. John Saville's Azure courses are legendary in the certification community.
Oh yeah, I've heard of him.
His AI-102 specific content offers a great structured learning path with whiteboard explanations that really help visualize the architecture.
That sounds super helpful for visual learners.
Definitely. And for quick revisions, there's a widely shared YouTube video called the AI-102 Study Cram. It's excellent for reinforcing key concepts, memorizing those tricky API parameters, and getting your head in the game right before you sit for the test.
Here's where it gets really interesting. We've got the study plan, we've got the resources, but let's pivot to the actual technical meat of the exam. The playbook outlines what I'm going to call the big 5 focus areas.
The essentials.
Right. These are the critical topics absolutely guaranteed to appear on the test. Let's run through them. First up, service endpoints. Let's talk about the plumbing.
The plumbing is a great way to look at it. You need to know your specific endpoint URLs for each Azure AI service. When you provision an AI resource in Azure, it generates a unique endpoint, basically its web address.
And the exam tests you on this.
Oh yeah. The exam will ask you to identify or format the correct endpoint URLs used to interact with the various services. And it's not just a generic URL. You have to understand how the region plays into it.
The region, like geography.
Exactly. If your resource is in East US, but your application is formatting the API call for West Europe, the whole thing breaks. It's the literal routing of your AI solution.
Okay, so you've got the correct endpoint URL. You know where the house is and how to route the data, but how do you actually unlock the door and start moving things around? That leads us right into the second major hurdle of the Big Five, API integration.
This is a massive portion of the exam. It goes way beyond just knowing what a GAA or CUSTER request is. You have to know how to deploy, create, and securely utilize different Azure AI services.
Securely being the operative word,
Absolutely. You will be asked how to send API requests with the correct headers. Crucially, it tests how you manage API keys and authentication.
because you don't want to just paste your key in plain text.
Right. Are you hard coding a primary key into your application, which is a massive security hole? Or are you using Azure Key Vault, or better yet, Entra ID for managed identities? The exam will test your ability to seamlessly and securely integrate these services into broader enterprise applications.
And speaking of enterprise environments, what if you can't hit the public cloud? That brings us to the third focus area, running services in containers. Why containers for AI specifically? Is it just about avoiding the "it works on my machine" excuse, or is there a specific Azure play here?
It's heavily driven by strict data privacy and edge computing scenarios. Imagine you are building an AI solution for a hospital that analyzes patient x-rays.
Okay, very sensitive data.
Highly sensitive. Due to HIPAA or other compliance regulations, they physically cannot send that image data out to the public Azure cloud. So what do?
You bring the AI to them.
Exactly. You pull down the Azure AI Vision container, deploy it to a local Kubernetes cluster inside the hospital's own secure network, and run the inference locally. The exam will test your knowledge of how to configure, deploy, and manage these disconnected, containerized environments.
Wow. It's not enough to just make it work in the cloud. You have to know how to bring the cloud to the edge securely.
You nailed it.
That hospital example makes it crystal clear why that's on the test. Which brings us to the fourth focus area, and this one feels a bit different from the highly technical networking and deployment stuff we just talked about. Responsible AI.
What's fascinating here is how the exam forces you to blend that highly technical implementation with rigid compliance frameworks. Ethics and responsibility are not an afterthought, and they aren't just a philosophical debate on this certification.
They test the actual engineering of it.
Yes, the exam heavily tests your technical understanding of responsible AI.
So what does that actually look like in practice on a test? It's not just asking, is bias bad, right?
Not at all. It covers the technical implementation of ensuring fairness, transparency, and accountability. For example, if you are deploying a generative AI model, how do you technically configure the Azure AI content safety filters?
Like setting the dials for what gets blocked.
Exactly. The exam might ask you to look at a JSON configuration and determine if the threshold for blocking self-harm content is set correctly. Or, how do you implement a transparency note in your system architecture? It tests which specific Azure tools, dashboards, and configurations you use to enforce those principles.
It's great that they treat it as an engineering problem to solve, not just a policy document. Which leads us to the final focus area of the Big Five, SDK implementation. And this really ties everything we've just discussed together.
It really does. You have to demonstrate your ability to implement those software development kits for the various services. Be prepared for questions where you're staring at a block of Python or C# code,
And you have to spot the errors.
or fill in the blanks. You need to know how to install the correct package like Azure iText Analytics, how to instantiate the client using your endpoint and credentials, and how to effectively call the methods to get the data you need.
So if a line is missing,
If the code snippet is missing a line for authenticating the client, you need to be able to identify that gap immediately.
all right, so we know what's going to be on the test. We know the Big Five technical pillars, and we know NLP is the heavyweight. Now we need the battle plan. Let's talk about the specific mechanics of sitting in that chair, navigating the question types, and managing the clock. Because passing a Microsoft exam is sometimes just as much about test-taking strategy as it is about knowledge.
That is very true.
What are we looking at mathematically?
The mechanics are tight. You will typically face around 52 questions in total, and you have exactly 100 minutes on the clock for the exam itself.
52 questions, 100 minutes. So you've got a little under 2 minutes per question. That moves fast. What kind of formats are we looking at? Is it all just A, B, C, D, multiple choice?
Not at all. You will have standard multiple choice questions, but Microsoft loves to mix it up. There are drop-down selection questions, which the playbook notes are heavily used to test your understanding of API and SDK syntax.
How does that look on the screen?
You might see a block of code, with 3 missing lines, and you have to select the correct method or parameter from a drop-down list to make the code function. You'll also see simple binary yes or no questions, usually a block of 4 or 5 of them based on a single scenario where you have to evaluate if a proposed solution actually meets the requirements.
And then there is the rearrange format, the drag-and-drop sequencing task. Instead of baking a cake, let's think about this like building a CI/CD pipeline or an architecture workflow.
Yeah.
How does it work?
That's the perfect analogy. In these questions, you're given a list of, say, 7 steps on the left side of the screen, and you have to drag 5 of them over to the right side in the exact logical order to implement an Azure AI workflow.
Give me an example of the logic there.
So if the task is setting up a custom text classification model, you can't train the model before you've tagged the data. And you can't tag the data before you've provisioned the language resource and created the project. If you drag the deployment step before the training step, the whole architecture fails, and you lose points.
This format really proves whether you've actually built these things in the labs or just read the theory.
Exactly. It separates the practitioners from the memorizers.
Okay, now we get to the part of the playbook that comes with a giant flashing red warning label, the case studies.
Oh, the case studies. This is the single most critical element for your time management strategy. The exam includes at least 1, sometimes 2, case study sections.
What makes them so daunting?
A case study presents a complex, real-world scenario. We're talking about a multi-page setup. Business requirements, existing technical architecture, security constraints, and data compliance needs for a fictitious company like Tailwind Traders.
That's a lot to read.
It is, and following that massive scenario, you will face a series of related questions that must be answered.
And here is the tactical advice from our mentor. You cannot skip these case study sections, and more importantly, you cannot navigate back to them once you finish that section and move forward.
Let me repeat that because it catches so many first-timers off guard. Microsoft isolates the case studies. Once you finish the case study questions and click Next section, that part of the exam is locked permanently. You cannot use the review screen at the end of the test to go back and change your answers in the case study.
So how do you manage your time knowing that roadblock is sitting there waiting for you?
Yeah.
And it might take 10 minutes just to read the architecture diagrams.
This is where the Mark for Review feature becomes your best friend for the rest of the exam. For the standard multiple choice or drag and drop questions, if you are unsure, do not sit there burning 5 or 10 minutes agonizing over a single SDK parameter.
Just guess and flag it.
Yes. Test anxiety will try to keep you stuck on one question. Don't let it. Make your best educated guess, flag it for review, and immediately move on. You need to bank as much time as possible.
To save for the case study.
Exactly. When you hit those locked-in case study questions, you need the breathing room to read the scenario carefully, cross-reference the business requirements with the technical constraints, and answer without panic. If you rush the case study because you burned all your time on a single code snippet earlier, you could lose 6 or 7 points in one shot.
That is exactly the kind of insight you only get from someone who has been in the hot seat and felt that clock ticking down. So, to bring it all together, what is the ultimate takeaway here? Our source material makes it clear that the AI-102 isn't just about passing a test to get a badge on your LinkedIn profile. It's a highly practical blueprint.
It really is a blueprint. When you look at what you are tested on, containerization for edge deployments, secure API integration with Entra ID, rigorous responsible AI frameworks, and heavy NLP implementations, these are the exact skills required to architect AI solutions that actually survive in complex enterprise environments.
It's about building systems that scale, remain secure, and operate ethically.
Right. My advice to you as you prep for this is to stay totally committed to the hands-on journey. Do not skip the labs. Embrace the frustration of getting an API endpoint wrong in practice or failing to authenticate a client in Python.
Make the mistakes before the exam.
Make those mistakes in your free Azure sandbox so you execute flawlessly on exam day.
And as you gear up to take on this challenge and start spinning up those resources, we want to leave you with a thought to mull over. The AI-102 exam places equal importance on implementing complex APIs and adhering to responsible AI through tools like content safety filters.
It's a huge focus.
It leaves you with a critical question to ponder as you build these highly scalable, containerized solutions. As these incredibly powerful Azure AI services become easier to plug and play via simple SDKs, does the ultimate responsibility for ethical, transparent AI shift more toward the developer snapping the pieces together? or the platform providing the tools?
That is the million-dollar question for the future of cloud architecture. Keep that in mind as you study the underlying mechanics of these services. Best of luck on your certification journey. You've absolutely got this.
Thanks for joining us on this deep dive. We will catch you on the next one.